All right, so varying the cube root of a quantity. So you guys off air have already explained pretty well why it is what it is. So explain why the mass of the ball is proportional to the cube. All right, so the thing you would start off with, the mass is obviously going to be dependent on the volume. Would we agree with that? So let's start with the volume. So that's our formula, yeah? So we know that the volume, is proportional to the cube of the radius. All happy with that? We all good with that? Okay, so if you went, okay, I would normally have V equals K R cubed. We're not going to do that. But you've got your constant of proportionality. And for us, in this case, we got 4 over 3 times pi, because they're all numbers. Okay? Now, and mass is proportional to volume.
Is proportional a little alpha fish line?
Yeah, you can do the fish. Yeah, so V fish R cubed. Yeah, that varies directly or varies in direct proportion. We're not using the fish this year, though. We used that last time. Mass is proportional to volume. Now, there is a particular reason that we can state that, and it's in the question.
It's made from one material.
Yeah. Yep. Used. Okay. If it was made of different materials, that would change it. Like, it wouldn't necessarily work proportionally. So that is it. It's a little bit of word salad, but that's all right. You won't have to do word salad too much. So now what we have to do is we have to write part A as a formula and hence show that the radius is proportional to the cube root of the mass. That sounds complicated until you think, well, volume is something times r cubed, and mass is also proportional to the cube of the radius. And what's our constant of proportionality normally written as? K. R cubed. So we are now saying that is a statement that the mass is varies proportionally. It's constant proportionality there with r cubed. So m equals k r cubed for some constant, so some number greater than 0. Therefore, r cubed, oh, sorry, get rid of that. Okay, we happy with that so far?
Yeah. Is k the 4 over 3 times pi?
Could be, but we're not worried about that at the moment. We're just going to use k, because at the moment we're doing it like we have been doing it for a sphere, but it doesn't necessarily have to be. We just want to keep it general. So 4 over 3 pi is a number, and we want to keep numbers out of it wherever possible. So this is a general thing. All right. Now I want to rearrange that so R is my subject, because I need to have it to show the radius is proportional. So rearrange that, and what do I get for R? Okay, so we're going to divide both sides by k, and then we're going to do the cube root. Happy with that? Okay, so that would be m over k, and then the cube root of that, correct? So m over k, and then the cube root of that. We happy with that? Okay. However, I want it in the form of y equals kx, something like that. I just want this constant by itself. I want my variables to be not on that. So what I'm going to do is I'm actually going to take this and go, okay, r equals cube root of 1 over k. Well, that's a 1. Times the cube root of m. Is everyone happy with what I've done? No? All right. I'm going to take this cube root of m over k. You happy with that thus far? So I'll just cube root there. Now I'm going to split that. M over k, I could write as 1 over k times m. Agreed? And so that's still a cube root of. Then I could actually write that as cube root times cube root. And so I'm going to bring the 1 over k and the m there. All right. So I'm just splitting it back. And the reason I'm doing that is because that is a number. Cool? All right. It also wanted me to do it as the cube root of the mass. So I needed to get the cube root of the mass on its own. All right, cool. Capital M, capital M. All right, now how has that helped me? Well, would we agree that the cube root of 1 over k is a number? Because k is just a number and all that. All right, and I can go r equals, let's call it L times the cube root of m, where L equals cube root, I'll get rid of this stuff, sorry, 1 over k. So what I've done is I've just defined a new variable called it L. Now L is just a number, and that number happens to be equal to the cube root of 1 over k. Everyone cool with that? So I've just defined another variable. The only reason I've done that is because r equals L times the cube root of m is much neater and nicer. Okay? But I've also said, yeah, but if you were subbing things in, they'd only give you a k, and I could sub it in because I know that L equals the cube root of 1 over k. So I could put a number in there, find out what L equals, then put L in and find out what R equals. Everyone happy with that? So I have just defined a new variable. This is something we will do a lot of. We will, what we do is it's called substitution. So I will make up L equals all of that because I don't want to have to write all of that 5 times. I'd rather just write L, and then over here I'll work out what L equals, and I'll just put that number in. It makes your life a lot easier. We do it in physics as well. When we've got multiple kinematic equations that are embedded inside each other, we'll just work out this bit. So I've got this and this and this, and I have to find A before I can work my way back. Find A, and then just put the number in, and then find that bit, and then just put that in. Okay, you want to be able to try and simplify it as much as possible. Everyone okay with that? All right, that has been now expressed with R in terms of the cube root of m. Everyone cool? Okay. Question C. We now need to write B as a formula and hence find the nearest millimeter to the nearest millimeter, the radius of a ball with 19 kilogram mass if a ball with a mass of 0.9 kilograms has a radius of 5 centimeters. Remember when we were doing constant proportionality earlier, I said the first thing we had to do was find that constant proportionality, the one we don't know. Okay, but they're going to give us a couple of numbers so that we can solve it. They've given us a couple of numbers and we're going to solve it. Okay, so the first thing is, what is our formula? Yeah, we've got the R equals L. Okay, so what we've got is they have given us these details here. We've got 5, because that's our radius, equals L times the cube root of 0.9. So I've replaced the m. So m equals 0.9 and r equals 5. Happy with that? So I have replaced it in this formula here. I have replaced the R with 5 and the M with 0.9. So what are we going to find when we do this? Yeah, we're solving for L. So that's the constant of proportionality in this particular one. Okay. So when we substitute it in, what do we get? You guys should be able to solve for L without having to do too much changing. You're going to divide by the cube root of 0.9. You've all got calculators. You've all done this, yes? Cool. What'd you get? What'd you get? 5.1787208.
1787208.
Excellent. So what we do now is we now know the value of L. Just a quick question on your use of calculator. You've just put stuff into a calculator and you just hit equals and it gives you answer. What is the next step you do before you do your next question? No. On the calculator itself. What have you guys traditionally been doing?
You press the answer button to get the exact.
Yep, but that's when you do the next question. I'm saying when you've just finished that question, what are you guys traditionally, what have you done? How do you clear it? Okay, that's the problem there. Sorry? Okay, so problem we've got. Okay, this is one of the more common things that happens. Yep. This is one of the more common things that happens. You watch, this will actually ask me to log in.
You don't even need to clear it, you just start typing.
Also, once you've got the answer, you can just keep going.
Yeah. And it becomes a new thing.
Yeah, I'm pretty sure you can press like.
Don't press on because that'll clear.
Yeah.
Correct. You do not press the on button.
Who does that?
Okay? It is the most common thing that I've found students who have not been taught, that have not been taught how to do it. Enter your school ID. I don't know what my school ID is.
Single byte, sir. Single byte. This is an online calculator.
Could you do sign with the
Yeah, I just did and I didn't like it. Log in with Casio ID.
I'm pretty sure this is your old calculator.
Yeah, there we go. All right. So when we do this, why aren't you bringing up my calculator? Oh, I don't like you. You're not very nice. Oh, I'll have to do it later. I can normally bring up the calculator, but I'm going to have to get it logged back in. All right, so when you do it, you do not press the on button to clear it because that will clear your history. You use the AC button or all clear button, okay? The reason you do that is, as Dexter said, when we do our next part, we want to be able to use the ANS button, which I'm assuming you all know means answer. Agreed?
Yeah.
Okay, so we've now got that L. So now what we're going to do is we're going to substitute in because we want to find out what happens when we've got an M of 19. Okay? So then we've got R equals L cube root of 19. Cool? Now, instead of the L in your calculator, you're going to use the ANS button.
How did the 1 on K become 19?
The 1 on K, because we just found out what L equals, and L equals that. And that's one of the reasons for doing it. We don't care what K is in this particular case. We were able to find out what L is, and L includes K inside it.
Oh, so, yeah.
Yeah, so we don't need to go back to find. If they asked us to find what K was, we could, but we don't need to.
Yeah.
So we've got a nice simplified version of it. All right? That was the quietest sneezes ever. Well done. Don't hurt yourself though. All right, so now you would chuck in. Now I've got ANS and then cube root. Don't forget to put a multiplication between them or a bracket, grouping symbol, I don't care which. What do you get for R in that particular case?
13.818.
Yeah, let's call it 13.8 centimeters. That's cool. I'm happy with that. Everyone cool with that? All right. For those of you who did not bother getting your calculator out, my concern is that you're not going to know how to use a calculator properly. It's really important that you bring your calculator and use your calculator every time. If you do not have a calculator, let me know. That way I can laugh at you. You're in extension maths. Yeah.
Why do you know the roughly equals?
Because it's not exactly 13.8, is it? It's 13.81 and then there's more decimal places.
Yeah.
Yep. So I'm rounding it. You could skip that and just put equals and then in brackets say 1 decimal place.
I thought
Yep.
you did.
You can. Either one I'm happy with. By putting the approximately equals to, I'm not telling them how many decimal places I round it to.